All right, so we are on page 2 of 1.2 notes. So the second page, it is asking us to use our calculator to find the limit of as x approaches 3 of 2x minus 7. So raise your hand if you have a numWorks calculator. Okay, so in numWorks, I'm going to show you numWorks first. numWorks, if you enter that equation in, we all know how to enter in a graph. Do I have to go back to the start? So you're going to go to your home, you go to graph and enter in the equation, and then you can either hit the arrow keys to trace. You can also type in what we're finding the limit as x goes to 3. So if I type in 3, enter, it will take me to that value on the graph. The TI is very similar. So if I go to my TI and I go to y equals, and I type in the equation 2x minus 7, and hit enter, and then graph it. And then if I hit trace and type in the limit as x goes to 3, I hit enter, it will take me to that value. Okay, Desmos. I personally think Desmos is harder for this type of thing, but you can also use Desmos. Maybe I'll show Desmos on the next thing. So I'm trying to find the limit as x approaches 3. So what I did is I put my cursor at x equals 3. It gave me a y value of -1. And remember, I have to look at both sides of the graph. Are both sides of my graph, so like is this side, I can let you write, is as I get bigger than 3, am I approaching? So like if I type in, I don't know, 3.001, is that getting closer to -1? If I type in a number smaller than 3, like 2.99, is that approaching -1? So what is that limit? So this limit is going to be -1. And that's because the limit as x approaches 3 from the right is -1, and the limit as x approaches 3 from the left is -1. All right, so go ahead and type in the next equation, the x cubed minus 1 over x minus 1. It seems like most of you have TIs, so I'm going to do it on the TI. So again, don't use alpha, y equals. Put the numerator in parentheses and then the denominator in parentheses. And use divided by. So it should look like that when you type it in. And when I hit graph, I'm going to just hit 2 to make sure this is what your graph would look like. And I'm finding the limit as x approaches what number? 1. So I'm going to hit trace and I'm going to put a 1 and hit enter. And the y is blank. So what does that mean is happening at that value? There's a hole. So like if I were to sketch a picture, it kind of looks like with a little hole there. But both sides of the graph like as I come from this direction and I come from that direction, they are approaching the same number, right? We have to figure out what that number is. So how can I figure out what that number is? Is back on my calculator because I don't have an answer for one. I'm gonna pick something a little bit bigger than one, like 1.01. And what number is that close to? 3. So if I do 1.001, again, it's close to 3. Now let's look at the other side. Let's do 0.999. That is also close to 3. So what is this limit going to be? 3. So basically on this graph, that hole happens at 3. All right, next is piecewise functions. So piecewise, if you can sketch a graph by hand easily, then do that. That is helpful to visualize what the piecewise graph looks like. If it's a more complex piecewise function, then it might take you too long to sketch it, so we want a different way. So many limits will be approached at the place where the function switches from one piece to the other. So usually if they give you a piecewise function and ask for the limit and that little inequality sign, where that breaks is where the limit is going to approach. So what you have to do is you have to find the left-sided limit, which is substituting the value on the left piece. And then the right-sided limit is substituting the value on the right piece. All right, so I know that's kind of confusing, so let's do an example, make it make more sense. So example 1, they give you G. G is a piecewise function, and I'm finding the limit as as X approaches 1. So if you look, that is where the graph splits. So I have 2 pieces and they split at 1, and that's the limit I'm looking for. All right, so what I'm going to do is I'm going to find the limit as X approaches 1 from the, let's do the left first. So I have to figure out which of these pieces is to the left of 1. Is it the upper one or the lower one? The lower one, because X is less than 1. So I'm going to find that limit. Now, when you look, did you learn direct substitution, AP Pre-Cal? Like you can take that 1 and plug it into the function. So I can take this 1 and just plug it in there. The 1 plus 1 is 2. Then I need to find the limit as X approaches 1 from the other side, which is from the right. So the right side is when we're bigger than 1. So that's the function X cubed plus 1. So when I plug in, do the direct substitution again, I take 1 and plug it in for that X. It gives me 2. Since those 2 values are equal, that tells me that these 2 pieces in the piecewise function come together, which means the limit as X approaches 1 of G of X is equal to 2. Do you want to try B? If you can try B, Where did you figure out that it's the notes from yesterday? Okay, so I set this up where I'm finding the limit as x approaches 2 from the left and the limit as x approaches 2 from the right. Do you all understand why I picked the equations that I did for the left and the right? It's based off that inequality. So now I'm going to put the 2 in for all the x's, and I'm going to trust you guys to do that math. What did you get? 3. Then I'm going to find 2 from the right, which is the other piece. When I plug them in, remember you square before you make it negative. And what did you get?
3.
3. So that means because those two numbers are equal, the entire limit of h as x approaches 2 is 3. Okay, so I chose not to sketch those because that would take me way too long to sketch the graph. But I want you to understand that this means that the two pieces, so I have 2 parabolas, will come together and meet at 2, 3, at the point 2, 3. All right, the next piecewise function, I can sketch pretty easy because they're horizontal lines. So I'm going to show you this one visually. So I'm finding the limit as x approaches 1 of f of x. And f of x is that piecewise function. So if I sketch a graph, here's 1. It's telling me that f of x is equal to 3 when x is not equal to 1. So 1, 2, 3. That means I'm going to have a hole here, but every place else is equal to 3. But when x is equal to 1, I'm at 5. So this graph is a horizontal line with a hole in it. And then I have a dot at 1, 5. And I'm finding the limit as x approaches 1 of f of x. So as I approach 1 from the right and 1 from the left, what y value am I approaching? 3. So that limit would be 3.
Question.
Yes.
How'd you know like there wasn't lines on the bottom? Because it equals 1.
Because this is saying when x is equal to 1, that y value is 5. So this is just at a point at 1, 5. This is saying everywhere x is not 1, it's always going to be 3. So when x is 0, I'm at 3. When x is -2, I'm at 3. When x is at 5, I'm at 3. So it becomes a horizontal line everywhere except for that one value. A lot of students will make the mistake on this question when it comes up on a test or a quiz. They will answer that. They say, oh, x equals 1, the answer is 5. And it's not 5. Okay, you do not do direct substitution. you are finding the limit as x approaches 1 from the left of f of x. Well, if I'm approaching 1 from the left, I'm at this one. If I approach 1 from the right, I'm also on this branch, which is 3. Okay, so that's the part that, you don't have to hit the target, you just have to approach it. All right, next we have, determining limits numerically. To solve numerically, you must generate a table. A table can be generated by hand by using the graph on your calculator or by setting the table on your calculator. This strategy can be used if you have access to a calculator and you do not know how else to solve the limit, or if a graph is difficult to read. So we are going to practice generating a table to make sure you know how to do that in your calculator. So I gave you a function x minus 3 over x squared plus 2x minus 15. And we are going to complete the table to find the limit as x approaches 3. So 3 is in the middle of my table. Then I picked numbers less than 3. And I picked numbers greater than 3. All right, so go ahead and type this function into your calculator. And hit trace to fill in our table. I'm more fluent than me. All right, so I think the easiest way to fill in the table is using my trace feature. So I'm just going to hit trace and I'm going to type in 2.9 because that's the first value. And it gives me that decimal. And then I'm going to type in 2.99. Hit enter. 2.999. And I'm going to type in 3. It gives me a blank. What does a blank mean? Undefined. So I'll start filling in the table here. You want to put a lot of decimals. All right, so the numbers in the table when you're finding a limit that are most important are the ones that are closest to that number. So you can't make a table and try to do limits and put in like 3, 4, 5, 6. Like that's way too far away from 3. So we're putting in numbers like super close. Yes.
How far would you go?
So, for instance, Delta Math, they create the table for you. So like if you aren't sure, like if you can't tell what this limit is, then keep adding 9s or 0s. So like if I can't tell what number that's going to go to, then I'm going to go back to my calculator and I'm going to try like 2.9999999. And then it's gonna tell me, so like the more decimal places you put,
Yeah.
the more accurate the Y value is gonna be. So like I couldn't really tell using this that it was gonna go to 1 or 0.125. Yep. So, you might have to make a table. Sometimes, like what we've seen on College Board is sometimes they give you a table and ask you what the limit is approaching. But sometimes you might need to create a table. Delta Math, they don't give you an equation. They just say f of x, and it generates a table for you by putting in numbers, and then you figure out the limit. So you don't have an equation at all. They're just saying, can you tell what number you're approaching? Okay, so we can see that this from the left, which is this side, that's less than 3, so that's from the left. I'm approaching 0.125. From the right side, the number's bigger than 3. I'm also approaching 0.125. So that means the limit is 0.125.
Certain numbers you can make so much.
So it's what the most digits that have in common.
Okay.
Okay, so like here, like 0.125, 0.125,
Yeah.
like if it went like 0.1251, and then this was 0.1251 something, and then you put that many decimals.
So you just want it to be.
Yes, you want it to be, it has to round to the same places. And if it doesn't, you chop them off. Yep.
Okay.
All right, so this one, I filled out the table for you. So we are approaching from the left, our numbers below 0. Approaching from the right, our numbers above 0. At 0, it does not exist or it's undefined. So what do you think this limit is? 2. And that's because the limit as x approaches 2 from the right, we'll just call it f, is 2. And the limit as x approaches 2 from the left of f is also 2. All right, when does a limit fail to exist? If a limit approaches infinity or negative infinity, that limit does not exist because there is no cap or there is no floor. If the limit from the right does not equal the limit from the left, that means the limit at that value will not exist. It's possible for one side limits to exist, but not the overall limit. And if a function oscillates between 2 values, that means it jumps. Like usually what happens is it jumps from positive to negative. Positive to negative, so it's oscillating between 2 values. So I'm going to show you examples, and we're going to show why this does not exist. And answer of DNE, which is does not exist, requires an explanation. So you need to be able to explain why the limit doesn't exist. So here, the limit as x approaches 2, there's your graph. What is happening at 2? As x approaches 2, what is the function doing? Going to infinity. So this limit does not exist because the graph is approaching infinity. Right, the limit as x approaches -1, so -1 is right here. Why does that limit not exist? I approach negative, as I approach -1 from the right, what is that limit? As I'm approaching -1 from the right, my y value is 1. As I approach -1 from the left, my y value is -1. So the limit as x approaches -1 from the left and right are not equal, because this limit was 1 and this limit was -1. And the last picture, the limit as x approaches 0 of sine of 1 over x. What's happening is it's jumping up and down. So as x approaches 0, f of x oscillates. I'm going to show you on your calculator just what that looks like. You can see. And you're really trading those stuff. Oh. So at first glance, oh, it looks fine, right? But if I zoom in, what's going to happen, like if I do 0.01, oh, let's zoom in.
That's it.
Zoom in again. So as you zoom in, it's just like jumping up and down and up and down. So that's what we call it. Okay, in summary, limits are y values. In order for the limit to exist, the left has to equal the right, and f of x has to approach a real number. If the limit does not exist, explain the behavior. Now, what's after these notes are just extra practice. So if you are struggling or have always struggled with limits, there's answer keys. So like if you just kind of like cover it up and try the problems on your own if you're looking for more practice on limits. So that's just what the next pages are. It's just added resources.
He's on the farm with.
Oh, this is